Welcome back, everyone. I hope you had some coffee and a short, nice break. In our next panel, we will have a look into practice and how companies are already shaping future. So we will talk about the future of plastics, and we will have different cradle-to-cradle solutions on this stage, and hear what actually is a possibility to work on this plastic problems we just have. Because you could say that plastic is one of the pests from this time, but it's also something we cannot imagine not having around us anymore. So plastics are a lot of times criticized. Even they have value for different topics, and because plastic is not plastic, we have here today different companies that are representing a different way on working with plastics. How does plastic has to look like? How do we have to have plastics for the future? What kind of materials and technologies do we need to use to actually have plastics used in a cradle-to-cradle way? I want to talk about this today with Reinhard Schneider, Michael Pooley and Anne Lamp. Welcome on stage. Thank you that you got here. I shortly want to introduce these to you because maybe not all of you have heard about them, but first I would like to start with the left, Reinhard Schneider. He is the CEO of Werner and Merz, and probably the most of you know their cleaning products called Frosch, so with the frog. And Reinhard Schneider is studied business administration and worked in different companies for many years. He was also chairman of the managing board of Werner and Merz, and he since 1992 he was also in the supervisory board of Werner and Merz, because Schneider is a descendant of the company's founders, and today he is managing partner and sole owner of Werner and Merz, and he also got a lot of prizes, for example the environmental award in 2019. I have also on stage to my right the CEO of IFCO SYSTEMS. He's CEO since July 2020, Michael Pooley. Welcome on stage as well. And IFCO SYSTEMS is working with Cradle to Cradle for a few years now as well, but they already implemented the idea of circular plastics for many years now. We will probably hear from him more about what they do with their company. And close to me on the right side, you see Anne Lamp. She is the CEO and co-founder of Traceless, a company that is working with bioplastics. And she studied process engineering and also worked on the fields of bio refinery. And she can probably explain to us quite good the difference between bio-based, biodegradable, home composting, bio-based and bio-based residuants. So thank you that you are here. Anna was also a long time participating in the Cradle to Cradle NGO as a volunteer. So thank you all of you for being here today, and we would like to start with a short introduction round where you can maybe explain to us a bit about your work on with your company on plastics and on Cradle to Cradle. Michael, would you like to start?
Yeah, thank you very much. Hello, everyone. My name is Michael Pooley. I'm with IFCO SYSTEMS. I'm the CEO. For those of you who don't know our business, IFCO was formed in 1992. So we're coming up to 30 years. And we're the first company that developed an outsourced reusable plastic container pooling system. So when you go to a retailer to buy your fresh produce, vegetables, fruit, other fresh groceries, you will often buy them from a reusable plastic container. And you'll see these all in the fresh produce aisles. And those are often our containers. The business model is based on a circular economy principle. All of our reusable plastic containers, or RPCs as we call them, are designed to be shared and reused by growers and retailers throughout the supply chain. And in the 30 years since our foundation here in Munich, where I'm based, we now have customers in over 50 countries globally. We work with over 300 different retailers, 15,000 fresh produce producers. And we have a pool now that's grown to 325 million containers all around the world. We operate this pool by sending our RPCs to growers. They fill them with their fresh produce. They ship them through the supply chain to the retailer. We then collect them when the retailer's finished using them, clean them, make sure they reach the best hygiene standards. And we have 93 service centers around the world to do that. And we wash over 2 billion crates per year in our system. So it's a plastics-based model, but it's based on a circular economy model where it's reusing the plastics rather than recycling. Typically, one of our RPCs will last about 120 cycles. And when it comes to the end of its life and it can't be repaired anymore, we will grind it up and we will use that plastic and turn it back into a brand new IFCO RPC. So it is truly circular. And we're the only company in the world that can do that. So our recyclate is used for exactly the same process, exactly the same products as it was originally intended for. So we don't degrade the value of the material during its lifespan.
Thank you very much. An interesting case. Next to us, we have Anne. She has a case that is actually not working with a fossil-based plastic. So maybe you can explain to us what you do.
Sure. So we are Traceless, and the basic idea behind Traceless maybe started 7 years ago when I joined the Cradle to Cradle NGO. Because this cradle to cradle mindset is what's made us start to think about new materials for the biological cycle. Actually, there are a lot of products that often end up in the environment because they're consumed, because they are small, because in many countries they don't have collection systems. Actually, 40% of all plastic waste ends up in the environment. So therefore, we need a biological cycle in terms of cradle to cradle. But materials, like basic materials for that, are rare. So the motivation was to produce a holistically sustainable material to reduce the plastic pollution. And what we do, we are a startup. We founded the startup 1 year ago, actually. So we're quite a young company. We use byproducts of the agricultural industry, so food production byproducts, and convert them into a novel natural base material for use in the plastic converting industry. And this novel material can then be used or processed into products that are consumed or might end up in the environment. So that is what we do. So we are scaling our technology right now, working with a lot of companies that are interested in changing their products into a holistically sustainable material solution. And yeah, very happy to be here and looking forward to the discussion.
Thank you, Anne. And next to me is Reinhard Schneider. And he is probably most known for his cradle-to-cradle engagement in the community. So yeah, but still you have the time for introducing you and your work as well.
Yeah, thank you very much. Well, as already mentioned, yes, we are the ones with the frogs, but let me maybe just share one chart to show in detail what we are doing. So our mission at the end of the day is to perfectionize circularity for packaging solution in our markets. So our markets are cleaning and also cosmetics within the quite big, huge market of fast-moving consumer goods. And we also try to provide good working circularity solutions, technical solutions in our open innovation policy, so that we also might be sooner or later some kind of role model also for other markets like the food industry and their packaging requests. So what do we do in detail? We started at the beginning of the millennium with first percentages of recyclates in our packaging. And in 2013, we already had 100% recyclates from the European bottle collection system in our bottles, in all our bottles of our brand Frosch. But then, of course, we looked for the best source for this recyclate, since we are using the mechanical cycle of cradle to cradle. And it was clear that we should take as much as possible from the source where the urgency is the most to avoid incineration. And this is, of course, the near household waste collection system called Yellow Bag in Germany, also existing in many European countries. So we've been able to include 20% of recyclate taken from the Yellow Bag, and the other 80% still from the bottle-to-bottle collection system. And this example went quite big. I mean, up to now, we could give back more than 500 million bottles to circularity for PET. But as we know, the most common plastic type for packaging solution is HDPE, high density polyethylene. And so we developed here 100% recyclate, which is taken also by 100% from this more or less soiled, not always completely clean source of the near household waste collection, Yellow Bag. Yes, we've been proud that we won numerous awards like the Bundespreis Eco Design, 6-time Germany Packaging Award, even once, which makes me very proud, the Cradle to Cradle Innovation Award in New York, and so on. So yes, it is possible to recycle on a top quality level. And this we also then wanted to prove for a sector that did not take recyclate at all up to now before we started, which is cosmetics. So we introduced the world's first 100% recyclate bottle with a total cosmetic suitability, conformity, taken also completely from the source of the Yellow Bag. And then the latest innovation was to do something also for the flexibles, because we know one of the most common plastic materials that end up still sometimes too often in the seas and otherwise is still incinerated because it's made of compound, is pouch, refill pouch. You can save at least 70% of plastic itself if you take a pouch instead of a bottle. But the recyclability was very poor. We changed that, so we have the world's first fully recyclable standing pouch from a monomaterial, where you can also detach the decoration layer that has all the pigments on it. So we're very proud that, well, we received Cradle to Cradle certification gold for this solution for all the criteria of Cradle to Cradle. So I think it's quite unique on the FMCG market. And last but not least, our last efforts for us, it's a quantum leap, is to well, improve and to enlarge the percentage of recyclate taken from the Yellow Bag from 20% initially to 50%, which is now the case for our PET bottles, and the other 50% is still coming from well, bottle to bottle source. So for the 4 most common types of plastic, find the best existing technical circularity technology, since the technical circle for our needs for barrier necessities is of course the mechanical circle. And we're going to talk about this, of course, later on, and I'm very happy and delighted to be here. Thank you.
Thank you, Reinhard Schneider. I think you made a good start into the discussion, talking about what kind of material we should use for what kind of scenario, because probably most of you know in Cradle to Cradle, you always have to look what is the usage scenario that your product is in, and then you can decide what kind of material you're using. In this whole discussion, there's always the perspective of talking about bioplastics, for example, and also talking about degradable plastic. Then there's the talk about actually recycling plastic. Maybe Anne, you can help us a bit, or you can help the people around the screen a bit about what is actually the difference about bioplastics, and not all plastics are biodegradable, so maybe you can help a bit about this.
Yes, of course. Yeah, the question is actually, what is the difference between bioplastics and bioplastic? That's actually the right question, because the problem currently is that a lot of plastics are called bioplastics, but actually they differ a lot. So in general, it's very common to differentiate between the source, the raw material, so either it's fossil-based or bio-based. Bio-based is mostly starch or sugarcane or cornstarch based, or fossil-based like crude oil. And then we differentiate between degradable and non-degradable. That's the classical differentiation. And of course, most plastics are fossil-based and non-degradable, 99% of all plastics. From the bioplastics that we have ones that are non-degradable or degradable. But the degradability means in most cases that it's degradable in industrial composting plants. So in your municipal composting plants, for example. So it needs to be collected, cannot degrade in the environment because it needs actually elevated temperatures for that. And then there are some materials that are even home compostable. That's even a quicker degradation, and they are also degradable if they end up in the environment. And there are just a few materials out there. That's, for example, where we want to offer a new solution because we need more materials in that field. And actually, to come to that home compostability, you need to look into nature again. According to the Cradle to Cradle principles, you need to produce materials that microorganisms are capable to digest and to break down. And also on the bio-based source, there's a lot of conflict when we talk about bio-based plastics, because in most cases food sources are used, and that is strongly criticized by most customers. So first of all, we should use the byproducts and non-food sources for the production of bioplastics. And that is also a growing field to use non-food sources for bioplastics. So to give a little sort over that field.
Very much. You said why you decided to use the kind of plastic you're using. Michael Pooley, maybe you can also give us an insight why you decided the plastics to use this plastics you're using in your cycle.
Yes, okay. We use polypropylene for our RPCs. That's a fossil-based, derived from natural gas. And we operate really within the technical cycle. And the principle of what we're trying to achieve is a reuse model. So, our view is that plastics are a very durable, versatile material that are particularly good at transporting things through the supply chain. And so we have no basic objection to the use of plastics, but what we obviously want to avoid is plastic waste and the single use of plastic so that they can be used many times. Our model is not a recycling model, it's a reuse model. And therefore we need to choose a plastic that has the right characteristics to be able to be reused many, many times, and also can stand up to the challenges of a supply chain where things are moved around in large quantities and carry large loads in pallets and in automated processes, and then can also be washed at high temperatures to make sure that they are very hygienic for reuse because they come into direct contact with fresh produce. So that's the reason why in our cycle, our technical cycle, we have chosen to use a fossil-based polypropylene. We would love in the future to look at opportunities to see whether there are materials that could be an alternative to that. Bio-based plastics may be an alternative in the future. At this stage, there aren't any that we've come across that are able to take the length of service, the duty that we require, but that doesn't mean that with further technical progress in the future, that can't be an option for the longer term.
We see within Cradle to Cradle, it's very important to look at the scenario we are using the plastics in, and you cannot just say everything has to be degradable or anything has to be long living, like in some discussions we always hear just it has to be long living, and then we see that we find this materials at places where we don't want them. So actually looking at the scenario, and with Werner and Merz, the scenario we have is that we need barrier functions, and also plastic has memory effects. So how do you deal with these problems or with these challenges?
So we also analyzed for a long time our different options, how to complete the circle. And then when it was clear that our barrier functions that we cannot ignore is that the liquid stays in the bottle, of course, even if there are solubles and surfactants part of the liquid, as is necessary for cleaning products, then also sometimes even some gas barriers. So there are numerous barrier necessities to be respected. On the other hand, if the plastic has a certain thickness, if it is a little bit more massive than a very thin foil, our findings were that the bacteria, they take too much time until they will digest into the deep of the plastic. So all our experiments, all our learnings were that if you have even a biodegradable packaging of biodegradable plastics for our categories, if you leave it in the oceans, it would not take, 450 years until it's biodegraded. If it's just fossil, ordinary plastic, it would just take 200 years to be biodegraded if it is the up to now known biodegradable sort of plastic, because it can go quickly if the material is very thin, which is not the case for bottles, because otherwise it's not a bottle, then it is a pouch, and there are other difficulties. And on the other hand, you need a type of bioplastic that maybe is not allowing all the barrier functions that you need for your product. So therefore we said, okay, we concentrate on the technical circle and find out what can be done there to make it really closed on a low level of energy needed, because there are many different technologies to recycle. I mean, there's also chemical recycling, for instance, which is using normally very high temperatures. So if you look at the energy balance of the chemical recycling and pyrolysis, it's a nightmare. So we go for mechanical recycling, and then it's all about, design for, well, circularity. You have to keep out the pigments. You have to keep out the additives that are not useful for the recycling process, and you have to stay for monomaterial. If you just can follow these simple 3 rules, then you can end up with a very high quality closed loop on a known level of energy necessary for closing the loop. This to do with the 4 most common types of plastic, that was our challenge, which we now did for PET, PE, polypropylene, and even LDPE for the flexibles.
Thank you. Yeah, so designing is probably one really good thing to think about. How should we design plastics in a way that they are really made for cycles, either the biological or the technical cycles? There are a lot of questions already here. You can ask me questions, or you can ask the panel questions via Slido, so please use this function, and I would put them into the discussion in a few minutes. There is one question already on the collection of these plastics, and maybe this is something that would also be interesting for the IFCO case. How are you actually collecting your plastic again, and how do you know that you get it back if you bring it into the market?
It's a very good question, and it's fundamental to the success of our business model, actually. It's no good having a reusable solution if you can't get it back. And so we've had to design the system to facilitate that. And that's both physical and in the digital domain. So in the physical domain, we design our RPCs to be folded. So when they're unfolded, they're like a box. And at the end of the supply chain, when they become free of their produce, they fold down, and the fold down ratio is really, really small. So our RPCs fold down to a size that's typically about 1/10 of their volume when they're unfolded. And that means that your reverse logistics leg can be very efficient, and as a result uses a minimal amount of energy and carbon to create that reverse logistics leg. And the other element is around how do you know that you've got your RPC back. So tracking and tracing them is something that's very important for us, and we spend a lot of time working with our customers so that they digitally transfer information to us about where they sent them, so we can go and recover them. In the US, all of our new RPCs have a RFID tag on them so that they can be scanned, so we know where they've gone. And in Europe, we have a 2D barcode on our RPCs so that, again, we can scan them so that we know where they've arrived and when they've come back to us. And that gives us a very good idea of, if we have a problem, if we have some losses going on somewhere in the supply chain, we can identify that. And in some cases, we even put GPS trackers on a small, statistically significant proportion of them so that we can see exactly what's happening in the supply chain, and we can go and fix any problems about recovery. But as I say, recovery is really the key, because without that recovery, then a reuse model just does not work. So that's how we do it.
And you would say it's not only an ecological benefit, but also an economic benefit doing this?
I think it's absolutely both. The ecological benefit is huge. Using a reusable packaging, our reusable packaging, the LCAs that we do suggest that it reduces the carbon footprint by 60%, and it reduces use of water in the supply chain by 80%, and it also reduces product damage, which is the real key point here, because the food waste in the supply chain is higher than it should be, by 96%. So, plastic is a great material for those things. But economically, our customers would not use it unless it was economically overall in the supply chain cheaper than using a single-use alternative. And that's, why the business has grown from 0 to the size it is today, because it makes economic sense for all of the users in the supply chain.
Yeah, thank you. There was a question from the audience regarding to also how should degradable plastics be collected? If, for example, in Berlin, the bio-garbage collection system assigned no compostable plastic. Anne, this is probably for you.
Yes, so the reason behind that is that current degradable plastic or claimed degradable plastics are not degradable even in these industrial composting plants. For example, PLA is a good example, very popular bioplastic that just doesn't degrade in the short time frame of these industrial composting plants. And they are producing a product, right? So they want to have a compost in the end that they want to sell. They don't want to find plastics inside. So nowadays, they banned these plastics from their industrial composting plants, which is understandable. So we need to come to better regulations regarding bioplastics. So what is biodegradable, what can be claimed biodegradable, and which products not. In the future, of course, we hope that there will be a clear differentiation between degradable plastics and actually not so much degradable plastics. But we also need to look beyond the German borders. So worldwide, the plastic pollution is a huge problem. And therefore, especially therefore, we are also designing products or designing our material. Because here in Germany, it always looks like everything is clean, right? Why don't we need degradables? But actually, a lot of plastics are littered into the environment, especially outside of Germany, but even inside of Germany. If you look, for example, at fertilizers or seeds that are spread to the fields, they are in most cases covered with plastics. So single small particles of plastics on our fields for fertilizers and seed purposes. Or if you look at all coated papers, papers are a lot of times coated with plastics. And what happens with this coated plastic if it ends up then in the paper recycling? And well, the plastic is separated from the paper, but the plastic then is either burned or gives microplastic into the wastewater. So there are so many applications where we actually maybe don't even know that there are plastics inside, and they will end up in the environment. And for all these cases, we need material solutions, and hopefully also in the future, we will have a clear regulatory framework that differentiates between materials that are suitable for these applications or not. And we have already the Single-Use Plastics Directive of the EU. They banned some single-use plastics, and well, in the first sight, it seems like, well, some straws are banned. What does that help? But actually, a lot of companies now, they see the clear differentiation between synthetic polymers for the technical cycle and actually natural polymers for the biological cycle. And it really helps for understanding and creating this mindset of technological or biological cycle. And we, as a small startup already, we feel that huge demand from big corporates that they desperately want to have plastic-free solutions, for example, for their single-use or small packaging items, where they also decide, shall I go to the technical cycle or the biological cycle? But for many applications, they want to go for the biological cycle because it's not easy to collect. It's not easy to recycle. For example, if you go to go packaging, it will in most cases end up in the combustion. So that needs to be bio-based and even biodegradable, because in most cases, if you look at cities, in most cases, these paper cups, they just fall out of the trash cans. So there are a lot of applications where biodegradable packaging is necessary, even though it is not composted in our German composting plants yet.
So we see that a lot of companies are already working on solutions, and they do it in a private sector. They have a lot of innovation there. But like Anna also said, and we heard it from Reinhard Schneider as well, we need a political framework for that as well. Right now, a lot of plastic is burned at the end. A lot of plastic is not really recycled. you get your material from old packaging and plastic, but how would you say, what would we need for a political framework and conditions to change this?
Well, actually, we don't need anything less than a one level playing field, which we don't have at all right now here in Germany. To give you an example, I mean, for me, it's one of the biggest scandals in environmental policy that the use of virgin plastic instead of the use of recyclate, which is fulfilling the circle, the use of virgin plastic is still subsidized by the German government, because whatever you make out of crude oil, you have to pay a lot of tax. If you're manufacturing fuel for cars or diesel or oil for heating, there's a lot of taxing on all that. The only thing you can do with crude oil that is not taxed at all is making virgin plastic. So this is making virgin plastic really seducingly cheap compared to recyclates. And this should not be in the future. I mean, the process of recycling, of course, is a little bit more sophisticated and costs more money than just take cheap oil, which is tax-free, and make virgin. So in industry, where there is a very strong price competition, like in our industry for fast-moving consumer goods, we always have to fight against cheap solutions of others that might only take very few recycled for some limited edition, and then the big majority of their assortment is still then made by the virgin material that just ends up directly in the waste incineration in Germany and will be transferred in CO2. So why not take the European plastic tax and well, organize it like it was foreseen by the European Union, that that those parts of the industry who are responsible for well, bringing virgin into the market should pay for this plastic tax. In Germany, it was decided that the ordinary taxpayer, so every one of us, has to pay the tax, so that no one responsible in the industry should be charged more. I mean, that's a complete annihilation of the steering idea that was foreseen by the European community. And the next thing is that, yes, we also should some designated legal framework of incentivizing recyclation. So if somebody is using recycling technology that is able to provide the best quality with the least of energy many times, why not, well, give him something back from the virgin tax that you just take from the responsible industries that still bring tons and tons of virgin into the market that ends up in CO2. So there is a lot of potential for improvement here. Yeah. Maybe a chance for the next legislation period.
Yeah, that's true. But there's also one question, maybe you can just answer to this as well, because someone is asking, are we already in a situation where all plastics products could be produced out of old and trashed plastic? Or why is there so much plastic still being produced? Because like what I heard from you, it's quite difficult to get to.
It's so seducingly cheap to take fresh virgin crude oil plastic instead of recyclate. And secondly, well, yes, you have to follow the rules I try to mention, which, for example, to leave color out of the plastic. So if you insist on making very colorful plastic, then of course the technical possibilities to have many circles in recyclation are limited. So therefore, you have to find other solutions to have colorful products. I mean, for PET, it's so easy because you can just can put some color from the food sector into the liquid like we do it, and then you have colorful products, but the PET stays completely transparent. For other types of plastics like HDPE, there are also solutions like having a very thin sleeve covered on the colorless recycled HDPE. So then you still have a colorful surface, which is only making very few percentage of the overall weight of the packaging and can be recycled in a different stream that ends up in gray. Also, this is possible, but you need some investments for that. And no one will afford these investments when the worst, ecologically worst option is still the cheapest. This is the drama of the market.
And probably it's also because of the design, because a lot of, like you said, a lot of products are not made in a way that they are possible to recycle. So there is not enough recycling plastic that you could use, because at the beginning it was already
There are huge reasons to incentivize also design for recycling. So this is the key for total recyclability, and not only recyclability, but together with the incentives for taking recyclate, then also the fact that not only you make it recyclable, but you then take also the recyclate, because while we are speaking, is incinerated for many, many tons is a lot of recyclable packaging that no one actually recycles, so it ends up in the fire.
Thank you. When we are listening to what you guys are saying, I think it sounds like, oh, it's so easy to do cradle to cradle. Maybe Michael Pooley, you can explain to us what needs to happen for companies to actually implement cradle to cradle, or how is this journey working, and actually was it so easy, or are there challenges in implementing it?
Well, I don't think that it was a particularly onerous thing to do. The collection of the data provided some internal challenge to our business, but overall, once we'd overcome that hurdle, the process of working with the Cradle to Cradle team to understand what we needed to do in order to achieve a certification level was fairly straightforward. We were very pleased to achieve the level that we achieved. We got overall a silver for all of our European lift lock RPCs at our first attempt, and we got gold for material reuse. But obviously that then provides a whole series of challenges to us as a business, because part of what we're trying to achieve with the Cradle to Cradle organization is continuous improvement. So we can't be satisfied with silver. We want to move to the next level. And what this has done for our business is given us a very clear roadmap of what we have to do to improve even further in the future. That's informing our ESG strategy overall. So we know what we have to do in the future, and we're very determined as an organization that we will continue to improve and continue to increase the level of our certification in the future. So I wouldn't say it was a difficult task. Yes, you have to be committed as an organization to put some resource in to not only collect the data, but then have a program for continuous improvement. But I think every company in the world should be thinking along those lines anyway. So for us, it was not at all a problematic process. We've certainly enjoyed working with Cradle to Cradle, and we'll continue to do so in the future.
Yeah, thank you. Talking about difficulties and challenges, Anne, you talk and work with big companies that are actually willing to implement your ideas. You just announced your cooperation with the company Otto Group, and they want to implement Cradle to Cradle and your products by the packaging. So this is something probably where you can scale your material quite good. How do you see what is actually happening? Why are companies like Otto asking you to actually change their material? And is it possible for you to actually scale your material that much that you can already work in this with these companies?
Yes. So to the last question, we are scaling the technology very, very quickly, and we are putting all our efforts in a very quick scale up, because what we actually are doing is, for many other companies, maybe they wouldn't even have started that, because coming with a new material, wanting to go into the plastic market, we just spoke about the price of plastics. It's a very price-driven market. So we need to scale fast to be able to produce in quantities to be competitive to plastics. And that's the innovation that we have, that with our material, with our production process, we are in the price range of plastics, of conventional plastics. What will help, I mean, we just spoke about the plastic tax. That would obviously also help if we could compete with the price of plastics plus the plastics tax. But that is our goal, to scale fast and to be able to bring this material into as many applications as possible. To the question why companies are doing that, I think companies start to understand that they have the power to influence the way how we produce and circulate our products, because actually anyone can bring into market nearly any product quality, and companies start to realize that they are also responsible for our linear production system. And actually the EU plastic directives forces a lot of companies to change now, because on the one hand side, they are afraid of more regulations, and they really want to have circular solutions. And on the other hand side, the customers, they are customers, they want to have truly sustainable solutions. It's not the time for greenwashing anymore. I mean, everyone is sustainable now when you look at their websites, but actually customers started to differentiate between real sustainable solutions and just greenwashing. So it's not enough to write in your packaging 3% biodegradable plastics inside, but you need to come up with a new strategy. So a lot of companies are now forming or reforming their sustainability strategy. A huge corporate announced that they want to be plastic free in 2025. Maybe we can help with that, but it's an ambitious goal. And so especially with the company Otto, they already decided years ago that they want to have a circular solution in 2020X. And that's why they already started working with us when we were not even founded, because they realized that change needs time, innovation needs time, and we need to start now with that. So these companies, they are willing to change, but what they need are supportive regulations on the one hand side, then affordable and available material solutions. That's also not very easy. And also product design innovations. And yeah, we are working with not only Otto, also other companies, and yeah, trying to bring that now to market fast.
Thank you very much. Thank you to all of you. We have come to an end already. I just want you to have like one last sentence, and please stay to this one last sentence. I want you to tell us if you have a wish for the new government in Germany. So yeah, each of you has the time now for one wish, please. Yeah, Anne, would you like to start?
Sure. So one wish would be to realize that we need to act now on circular solutions, and that we need all solutions. We need the reuse solutions, we need the technical recycling solutions, and biological cycle solutions.
Thank you. Michael Pooley, would you go next? What's your wish?
I think I probably agree with Herr Schneider. You know, I think that it would be good to reflect the true cost within the taxation system, so that it encourages complete system redesign, you know, design around product end of life, and also, you know, how you can incentivize people so that, say, for instance, recyclate streams can be used more efficiently and more effectively, because at the moment, Germany's pretty good, but it's nowhere near as good as it should be. And globally, the efficiency with which we are able to recycle and the effectiveness of our recycling is pretty poor. So I think that some sort of financial incentive so that your system reflects the true cost would be good.
Thank you. And Reinhard Schneider, last but not least, your wish.
Well, as already mentioned, the one level playing field means no hidden subsidies for the wrongest method to treat plastic, which is from virgin to fire. And I think the consumer is far more developed in positive ecological thinking. We see this in the development of market shares. So hopefully also the governments one day will be more courageous to find the right framework for that, to supporting the right attitude that so many consumers already have.
So thank you very much to all of you. It would have been nice to see you in person in Mainz, but I think this was also a really nice and intensive discussion. So thank you very much for your input and your insights. I think everyone was really happy to listen to you. Now we have a short break where you can do again networking, and I ask you to come to the Zoom space called Foyer Marktplatz, and there you can actually have a discussion with other participants of this Congress. So please be there at 11:25. So now just move over to the other space, and then at the end, again in like 10 minutes after that, we will see each other again here with a keynote from Marcella Hansch from Everwave. Thank you very much.